Well, all right, ladies and gentlemen, welcome to our Week 10 materials. I know this is the moment that many of you have been waiting for. You're about to graduate. See, you were a square, now you're going to become a cube. Or you were a circle, now you're going to become a sphere. So we're going to jump into the world of 3D modeling using AutoCAD as our modeling tool. And that makes sense, because you already know how to use AutoCAD. And it's true, there are other 3D modeling programs out there. And some of them are quite excellent. I won't lie to you. Some of them are amazing. But you'd have to start from scratch in order to learn how to use them. And since you already know how to use AutoCAD, it only makes sense that we continue on using it. So, some of the stuff we're going to learn in this unit, locating 3D workspaces and 3D tools, making and changing, modifying 3D primitives, using Boolean logic. That sounds complicated. It's really not, though. Understanding the purpose of the user coordinate system, navigating the 3D environment, and creating 3D geometry from 2D lines, and then adding some features like fillets and chamfers to solid objects. Now, before we jump into the lecture, here's some information I'd like you to consider. These are the high points that we're looking for as we go through this material. So, what are some reasons we'd want to work in 3D rather than 2D? Have you ever thought about that? And then, what is the World Coordinate System, the WCS? What three types of models can you make in AutoCAD? What three types of 3D models can you make in AutoCAD? What are the cons or the disadvantages of wireframe modeling? What are the disadvantages of surface modeling? And why is it advantageous to work with solid models? What is a primitive? And what is constructive solid modeling? There's a little button we're going to work with called the Solid History tool. Again, we're going to talk about 3 Boolean operations. We're going to talk about union and subtract. Learn what they do. So as we're going through the material, make sure you pick up on these points as part of our lecture. So without further ado, let's fire up AutoCAD. All right, and we'll ask AutoCAD for a brand new clean drawing. And it would make sense to ask it to use your template to make that brand new clean drawing, right? So how about a new file based on your template. All right. And then giddy up. Now, we're not going to be working in paper space right now. We'll be working over in model space. And then here we are in model space. Now, the fact is, you've been using AutoCAD as a 2D drawing tool, and you've done that consistently since the INDR B12 class. Right? So you have a good understanding of how the 2D tools work, and we've worked with the Home tab tools quite a bit. You've even played around with the insert tools. We've worked on the annotate tab with some annotation tools also. We're going to make a leap though into 3D, that third dimension, and if we take a look, right, we know that AutoCAD draws 2D geometry quite easily. The fact is though, the third axis, the third dimension, has always been there. You don't really think about it maybe, but the view cube lets us find it. And if we see down here, we have the user coordinate system icon. Here is Y and here is X. Well, guess what? There's a Z. And the Z is coming out toward you. You just can't see it because it's coming off the screen. But if we were to click in the corner of the view cube, well, then we would see that Z axis, right? And now we're looking down on our 2D geometry from a 3D isometric perspective. And you can use the view cube to orient yourself and move around in 3D if you'd like. And then if you want to get back to a flat view, you just click on one of the flat faces of the view cube. So no doubt about it, we've had a 3D environment in AutoCAD since day one. It's just that we weren't using it, which is okay. Alright, so I'm going to create a little bit of geometry here. I'm going to create a rectangle that's 3 by 3. I'm going to look at it in 3 dimensions. And then we're going to talk about how do you create 3D models. And the basis for 3D models is 2D line work like this. So, the first kind of 3D model ever created was what I'm about to show you. I'm going to grab this rectangle and I'm going to click the copy command. And now when I copy, pay attention to the direction that it's moving in. Do you see the little tag next to my cursor? It's saying polar, and it's giving me the distance, and it's saying it's going in the Z axis, right? So I just copied it 3 inches above the Z axis and above the XY plane. And what you see is a rectangle floating in space here. So now what on earth is this thing? Well, if we take our 2 rectangles and we connect the corners using object snaps, what we're going to find is we have created something called a wireframe model. Fancy, huh? Now, I get it, you're probably not that impressed. The fact is, though, in the mid-1980s, people were wetting their pants in glee when they saw this, because this was hot stuff, okay? Wireframe models describe a volume. Now, they don't have volume because they're just made of lines, and these lines don't really even have thickness, right? They're infinitely thin. But they do encapsulate volume, and they give you a rough idea of a 3D shape. If we were to draw a circle with maybe a 1.5 radius, we'll do the same thing. We'll copy it up into the Z-axis, 3 inches. And you might say, how the heck are we going to show this as a 3D model? Well, believe it or not, the method was drawing some lines again and connecting the quadrants from one circle to the quadrants of another circle. And now what we'd be looking at is we'd be looking at a bunch of edges representing a cylinder. Yeah, not exactly super high tech, is it? So understand that this is the beginnings of 3D modeling back in the day. Alright, these are called wireframe models. Now, the bad thing about wireframe models is this. Not only do they look kind of ghetto, but they are ambivalent, or they are hard to interpret. And here's what I mean. We see the lines that make up the edges of this wireframe model. So now I'd like to ask you, which one of these faces is closest to us? For example, is this face here? Use my pen maybe. Is this face here closest to us? Right, and then that would make this like that, and this like that. You see, that'd be one way of interpreting what we're seeing on the screen here. But maybe that's not the case at all. Maybe this face is closest to us, right? And it's hard to tell because we're looking through things. So we really can't be sure the orientation or the position of this thing in space because it's a wireframe. So not only does it look kind of dumb and kind of low tech, you know, it also is ambivalent. It doesn't give us a real clear interpretation. So this is a wireframe model, and I'd invite you to do the same thing, you know, draw a square, copy it up into Z space, connect the corners, do the same thing with your circle, and you can say, hey, I created some amazing wireframe models today. Can you think of any other disadvantages to using wireframe models? Well, imagine your favorite video game, right? If you play these immersive 3D video games, imagine your favorite video game if everything was in wireframe. Like, you'd be able to see through everything, right? You would be able to hide behind anything because we'd see you. And everything would be lines. I mean, the screen would be full of billions of lines. It would be kind of impossible to see anything. So wireframe models really have a lot of disadvantages, and they are typically not used. Okay, but you do want to know how we start with 3D modeling.